Okay, so, and just to remind folks, if you have any questions, please put them in the chat. We will have a discussion afterwards, a little panel discussion. So you can put your questions in the chat and or just take yourself off mute when we're at that part of the present or of the session. Remember that you can use speaker view, and please have your audio and video off unless you're speaking or asking questions. And just a reminder that this presentation is being recorded and will be posted online. So I just have a couple quick slides I wanted to make sure folks were aware of. Some new resources have recently been published. Both of these resources on the screen here are through the National Research Council's life cycle assessment through, low carbon assets through life cycle assessment initiative, which is known as the LCA squared initiative. Both of these documents are really, I think, real key documents for the industry going forward. The first is the national guidelines for whole life cycle assessments. So this is the first time we have a common national rule book on how to perform life cycle assessment. This is the most in-depth North American version of a document like this available. Up until now, people have been using European standards and other less detailed standards. So this, I think, is going to become the new de facto, rule book that folks are going to start using. And when we all start using the same rule book, it makes the results much more comparable and more valuable to folks. So I'm really excited that this is out. And then the second resource, I'm proud to have been the primary author on. It was also through the NRC, and it's this primer for government procurement officers, but it can really be used by anyone involved in concrete procurement in anywhere. I was going to say in Canada, but it's pretty much applicable globally. So it just has a lot of resources about what is low carbon concrete, how can we, what can we ask our suppliers to make sure that we're getting a lower carbon product. So you guys are going to hear a lot of those strategies today from our speakers. We will share these slides as well, and there are links on these slides where you can get these resources. Also wanted to make sure folks are aware of this new tool called the BEAM estimator that was recently published by the Builders for Climate Action. This is a whole building life cycle assessment tool that's free, and it's specific for smaller scale construction. So it's designed for residential homes. So anyone that's just interested in working on smaller residential homes and looking at the carbon footprint, this is a great new free Canadian resource that you should be aware of. And finally, just wanted to announce some news that this isn't Ontario specific, but it is a precedent that is important, that it's showing the industry movement, that in Vancouver just yesterday, council approved a new set of rules requiring buildings to report their embodied carbon at building permit stage as of July 2023. And also there's a requirement that the value reported can't be an outlier, basically. It can't be 2 times above an average value. And then in January 2025, they will need to demonstrate a 10 to 20% reduction based on the building type. So that is pretty exciting. I think that's officially the first municipal policy in Canada that is going to be regulating low carbon for buildings in general. The Toronto Green Standard version 4 requires something similar for city-owned buildings, but not for the general public's buildings. So this is the first law that will be applicable to the public. And that is all I'm going to say. So I'm going to hand it off now to Bart to Sarah, to Sarah to start off the presentation. And yeah, really looking forward to hearing from our speakers. So over to you, Sarah.
Thanks, Ryan. And thanks, everybody. I was planning on being there in person, but unfortunately had to switch to virtual last minute. I've got a bit of a cold. The tests are all negative. But still wanting to be safe and potentially prevent you all from at least getting my cold, so I can be this evening's Typhoid Mary. So I'm gonna see, might be a little bit rusty on getting the Zoom going here. I don't know how to go back, but anyway, that's okay. So there we go. So 3 quick things I really want to cover in my presentation this evening, really, which is just to cover what embodied carbon is, the role of greenhouse gas emissions in the production of cement and concrete, and where they are, and then talk a little bit about our plans to achieving carbon neutrality for concrete, because as I will talk about later in my presentation, really, when you're talking about GHG emissions in concrete production, you're really talking about cement production. So maybe first, let's talk a little bit about embodied carbon. So this is a schematic of a typical cradle to grave life cycle assessment, which shows each phase of the building's life from manufacturing through each of its materials, through construction, operation, maintenance, and eventually demolition. And each of these stages result in carbon emissions. And so when we talk about a building's embodied carbon, we're really focused on two main elements. So there's the embodied carbon of the materials, the extraction and the manufacturing of the materials that go into the creation of the building. And then there's the actual construction. So it's the transportation of getting the materials to the construction site itself. And of course, sometimes we also talk about end of life carbon impacts from decommissioning infrastructure. So, another way that you often hear folks talking about embodied carbon is the upfront carbon in infrastructure and in buildings. And so embodied carbon is not only a significant, but it's also, as you'll see later, a growing source of GHG emissions. So buildings account for almost 40% of global GHG emissions, but about 25% of building emissions are associated with upfront. It's in total, it's estimated that about buildings and materials and construction account for about 11% of global emissions. And just so you know, that equals about 4 billion tons of carbon in 2017 numbers. Okay, there we go. So embodied carbon is gaining attention, is becoming more and more important as an area of GHG to reduce as buildings become more efficient. So, typically we look at buildings, particularly as they get higher in performance, more energy efficient. We can see why the attention on embodied carbon is going to grow. Certainly, I would say over the past maybe 6 to 8 years, policymakers, decision makers in government have certainly focused on how to reduce operational carbon, everything from low carbon fuel standards, energy efficiency programs, everything from new windows to grants for deploying heat pumps or smart grids, district energy systems, etc., have all really focused on how to reduce the operational energy. And you also see that in building codes as well. Lots of focus on net zero energy and maintaining, reducing the carbon energy footprint of buildings. And so now there's really a growing international consensus on the importance of embodied carbon. And how important it is to actually tackle and reduce these emissions. Architecture 2030 estimates that embodied carbon will be responsible for almost half of total new construction emissions between now and 2050. So this will, maybe be, we'll call it like the self-promotion slide of the evening. But a big part of our construction story and concrete's environmental story is actually about volume. So concrete is the most consumed material on the planet after water. We use twice as much concrete than any other, all other materials combined. This is driven by the fact that concrete is not only relatively inexpensive, it's extremely versatile. It has a host of structural and performance characteristics that are really hard to replicate in many situations. And also, concrete's an extremely resilient building material. So, as we start to think about the impacts of climate change and we start thinking about adaptation to climate change, concrete certainly has a very, very valuable role to play. When we also think about, economic benefits of concrete, it's pretty much available anywhere because it's manufactured from abundant local sourced materials. And so, you know, as I'm sure Bart will say, there's a concrete manufacturer in every community. Here we go, maybe, okay. But, you know, also we have to talk about GHGs. So the most significant portion of GHGs in concrete comes from the production of cement. And up to 8% of global emissions comes from the cement produced to make concrete. And in Canada, that's about 1.5% of Canada's GHG emissions in 2017 numbers. So, you know, deep cement and concrete decarbonization technologies are going to be essential to decarbonizing the built environment and also meeting Canada's climate reduction targets. Just to kind of illustrate my point, I wanted to borrow an example from Architecture 2030, which is an example of an office building. So if you look at the graphs that I've provided here, you'll see that materials make up the most significant portion of embodied carbon. And of those materials in a building, you know, overwhelmingly concrete is the most used building material. And of course, you know, with cement being up to 80% there, you can see that tackling emissions in cement will be key if you're looking at reducing embodied carbon GHG emissions in a typical building. Why am I not switching here? Hold on. Oh, there we go. So, you know, the last 2 years, lots been happening in the news, and we would argue that, you know, the years of COVID, of the Ukraine invasion, all incredibly important. But we also want to talk about the fact that, you know, these have also been very important years in terms of the climate change conversation. And really, you know, just kind of want to spend a few seconds talking about where do cement and concrete fit into the embodied carbon discussion. Must have missed a slide there. Okay, sorry, the slides on the screen aren't following the ones that are on my slide deck. That's okay. I will just jump ahead. So really, from the cement side, we're really interested in creating our own roadmap and promoting collaboration across our sector to demonstrate how we're going to reach net zero carbon concrete by 2050. And for us, this requires and necessitates working with partners across the entire value chain to deliver this aspiration. Our roadmap is focused on what we call the 5 C's. So these are the 5 things that you can do and the 5 actions or the 5 areas that you need to address along the value chain to reduce GHG emissions. So that's clinker, cement, concrete, construction, and carbonation. So clinker being, you know, the main component in cement, cement being the main component in concrete, construction, you know, design, use, optimization, making sure that you're not ordering too much concrete for the job. Carbonation is the natural absorption properties of concrete over its lifespan to absorb carbon out of the atmosphere. And our roadmap is really going to focus on enabling policies to support the transition. So everything from carbon pricing and regulations, but also the importance of technology investment and financing, performance-based codes and standards. So codes and standards that operate rather than on prescriptive approaches, but operate on encouraging improved performance and supporting innovation over time. Obviously, transparency and disclosure are huge for our industry. You know, we have made tremendous gains in terms of our level of transparency and disclosure on environmental product declarations. Low carbon procurement, which I'll maybe talk a little bit more about if my slide deck allows me to. And incentives are also large. And another thing that's not mentioned here, but also just continued research and innovation in our industry. You know, we believe right now that there are existing options to get us to net zero today. But is the technology all necessarily ready? Do we have all the tools that we will necessarily need to reach net zero? No. And so, part of our industry's commitment to reaching net zero is also working with partners on continued research and innovative approaches. And maybe finally, I'll say, oh, okay, so my slides are out of order. Interesting. Okay, well, so let's see here. I'm just going to kind of bounce around a little bit. Okay, so I'm not sure how this happened, but for some reason the slides are out of order. So now we get to test my ability to be nimble on a fly, speaking in a room full of people that I can't see. This is great. Okay, so, I spoke a little bit about procurement and its importance. Procurement strategies are increasingly being recognized as a major climate policy tool. And this is super, super important for our industry. The only way you're going to do anything differently is by buying things differently. And, the regulatory environment, carbon pricing, fuels policy requires our industry to reduce emissions. But there also needs to be at the same time a growing market to purchase the low carbon materials that we produce. And that is why, procurement policy in terms of spurring market uptake, building education and adoption for lower carbon building materials like lower carbon concretes is incredibly important. So, in Canada, we saw, a heavy focus on industrial decarbonization in the Healthy Economy, the Healthy Environment, Healthy Economy Plan, or as I like to call it, the HEHE. Certainly, the government of Canada has focused on reducing embodied carbon in its own green government directive, which is focused on what government purchases for its own use. There's continued collaboration we're seeing between the US and Canada on the Greening Government initiative. And, the United States certainly has taken a leadership role on procurement policies that they call Buy Clean. And then, of course, on a global scale, there's the UN Industrial Decarbonization Initiative, which Canada is a key player in, working with governments across the world on low carbon procurement policies to support government. So let's see what my mystery next slide is. Oh, okay, good. So it's still on procurement. This is good. So, in addition to the importance of procurement policies, we're also seeing a proliferation of procurement policies focused on cement and concrete. Particularly, I mentioned the United States taking a leadership role both on a state level and on a national level to support Buy Clean policies and really reducing carbon emissions in the built environment. Okay, we are also out of order here, but anyway, so concrete's pathway to carbon neutrality takes us on a series of steps between now and 2050. To date, it's looked at things like improved energy efficiency and experimenting with making lower carbon cements, such as Portland limestone cements and blended cements that can reduce GHG emissions today. Increasing uptake of low carbon fuels is incredibly important, but also important to think that from the cement side, we have two types of emissions, right? We have both process emissions and combustion emissions. And so innovations around carbon capture, utilization, and storage will be essential to helping our industry reach net zero by 2050. And the ability to utilize perhaps some of the carbon that is stored in concrete production is definitely an area identified that we are definitely interested in more research and innovation. Our quest to net zero demands collaboration across the entire value chain. So it involves everything from the materials production side, clinker replacement when cement is manufactured at the plant, the design and construction stage. So as I mentioned, optimizing the use of concrete, using not buying more or bringing more to the site than you're actually going to use, encouraging the increase of the lifespan, in its use, building energy consumption, having a material that's incredibly resilient to climate change. But then end of life is also an important, and actually I will say often forgotten part of our value chain, which is really, allowing for the use of recycled, decommissioned and recycled concrete to be used. There's a huge amount of carbon savings to be found there. And it also helps address a circular economy problem. Aggregates are not a finite resource, and allowing us to reuse our own recycled materials would be a way of addressing that challenge. Sorry. So maybe finally, I'll just talk a little bit about our collaborations and our leadership to date in terms of developing our decarbonization roadmap. So Canada's cement and concrete industry, in collaboration with the Government of Canada, have partnered together to establish Canada's industry as a global leader, and Canada's a global leader in net zero concrete. We have collaborated together to figure out how we're going to achieve a reduction of 15 megatons cumulatively of GHGs by 2030, and then ongoing additional reductions of 4 megatons annually. To do this, we are proud partners in an industry government working group. BART is also a part of this working group that includes the National Research Council, which Ryan talked about at the beginning, the Standards Council of Canada, and then and of course with other ministries such as Treasury Board of Canada, Natural Resources Canada, etc. And so that is it. Thanks very much.
Thanks, Sarah. That was great. We'll hear from Bart now. Great. Emily, if you can just re-spotlight the room and maybe you can unspotlight Sarah, that'd be great.
So thank you very much for your time today. My name is Bart Canters. I'm the president of the Ready Mix Concrete Association. So I'm just going to go through and talk a little bit about what we're doing here in Ontario, but applies across the whole country regardless. So as Sarah was talking about before, concrete is a truly local material. If you look at Ontario, we have 5 cement plants that produce the cement that we use here in the province. We haul aggregates from the local communities to build the local communities. So typically, the materials that we're using for concrete, we're only traveling 40 to 50 kilometers from the location of a plant. That's why there's 270 concrete plants in the province here in Ontario, and we're using local materials. So while cement represents a small component of the actual concrete that we use, it has a very significant carbon footprint, as Sarah was talking about. So we're going to be very upfront about that. And again, we've seen some very drastic improvements over the last 5 years when it comes to different cement sources. But the elephant in the room when it comes to cement is the fact that we're heating limestone up to 1400 to 1600 degrees C to create clinker. So there's 2 carbon sources in that cement. It's the heat that's needed, or the energy that's needed to generate that heat to literally melt the limestone. And that's about 1/3 of the CO2 that's produced. And then the second component, and the bigger component, is the chemical reaction that takes place when we turn limestone into clinker. It releases carbon from the limestone, which then reacts with oxygen and goes up the stack of CO2. So that's one of the critical chemical processes that we have to deal with. And there's a lot of new and innovative technology that's taking place within the cement industry to try and address that, but we'll skip over that today. So jumping back to accounting, and it's really, I have to point out, it's the design community and the contracting community that have really been pushing us aggressively. You've been aggressively pushing us, let me stress that, to step up to the plate and quit giving BS and give us the numbers that we need to do true carbon accounting. I've been participating along with Ryan in the LCA Squared initiative with NRC for the last 2 years. And again, it's really pushing the industry. So back in 2016, the ready-mix concrete industry across the country created an industry average EPD for ready-mix concrete. So back at that time, we were just averaging across the whole country. And again, for North America, we're using product category rules. We're trying to standardize the ways that we do calculations so that we have repeatable data that you can use when you're doing your evaluations. So again, I won't get into too much of the details there. It's fairly straightforward. When we get down to the nuts and bolts of what happens at the concrete plant, there's really 2 key components. So to be honest, from a ready-mix concrete producer standpoint, we're a mixing and delivery industry. So we're taking sandstone, cement, water, chemical admixtures, blending them in the right ratio in a concrete plant, loading them into a ready-mix truck that you see in the image here, mixing that material for 3 to 5 minutes, and then driving out to the job site. So our major CO2 impact from the concrete side is the diesel fuel that we use for mixing the concrete in the truck and then driving out to the job site to make the delivery. So those are the key things that we have to look at. So again, we have to look at other fuel sources like hydrogen, moving to batteries, other things that we could do at the concrete plant. We supply concrete year round. So again, concrete plants are set up for winter construction. So we have natural gas is probably our second major input at the concrete plant. So again, we're heating water, we're heating our sand piles to be able to make material during winter. Electricity is the next one. So again, we're very fortunate here in Ontario to have a very relatively clean grid, so that's great. So the more electrification that we can do at the concrete plant, that's going to have positive impacts. And then lastly, we have almost 4,000 ready-mix trucks across the province. So again, there's things like vehicle maintenance, grease, oil, all of the maintenance idea or aspects of the industry, they have to be captured in our EPD as well. So we're getting a true picture of what we're doing. So next we get to the raw materials, and we've talked a little bit about that. So again, for us, it's what are the impacts of the various raw materials? Cement has the biggest impact. It's that 80% impact. So again, we have to look at trying to optimize that. But again, diesel fuel again comes out when it comes to delivering materials to our plants. Again, aggregates make up a significant portion of our material. We have to extract that, haul it back to the concrete plant. There's diesel implications there, and then water and chemical admixtures. So we could probably spend an hour talking about the different levers that you could pull to try and reduce your carbon footprint when it comes to concrete. Again, you've probably heard many of them. Making the switch in cement types from GU cement, general use cement, to Portland limestone cement or GUL cement has a huge impact, 10% reduction. We're seeing massive switchovers across the country as you do that. Maximizing the use of supplementary cementing materials like slag and fly ash or other innovative new products. Again, we've been pushing those for 20, 30 years because they also have the added benefit of increasing the concrete performance and durability. So there's a double benefit when it comes to pushing things like supplementary cementing materials. We get higher strengths, lower permeabilities, and lower carbon footprints because they have a lower carbon intensity. So again, we're seeing a lot of press for that. Then we get into simple things, like when it comes to specifying lower strengths, utilizing all of the strength that you've specified. So again, to be in its simplest terms, the higher strength you specify in a drawing, the more cement we put into the mix, the higher the carbon intensity. So again, if you need the strength, maximize its benefit, make sure that you get good value there. Chemical admixtures, we've used lots of those to try and improve the concrete, but we'll leave that off. So back in 2016, we went through, we tried to do an average for the 7 regions in the country. And the issue when you start doing averages and doing the annual or analyzing data across the whole country, it gets very difficult to try and get accurate data. So that's what we did back in 2016. After using that data for 5 years, many of the ready-mix producers had some fundamental challenges with averaging when you have different supplementary cementing materials in every province, when you have different cement plants from province to province, when you have different aggregates from province to province, from a technical standpoint, doing that kind of averaging just doesn't make a lot of sense. So with significant financial support from the National Research Council, over the last 8 months, we've been working to create 7 new regional EPDs for each region. So for example, I'm showing here in Ontario, we came up with the 23 or 22 most used concrete mix designs. So we went through, surveyed our members, found out what are people actually using on projects, because we want to try and capture as much. If we're going to tackle the carbon challenge, we need to identify where are the high volume applications. We need to optimize those as soon and as quickly as possible. So what we've done in this basic breakdown is identify, here are the different mixes that we're going to use. In Ontario, we primarily use slag as our supplementary cementing material. So we've identified 4 different levels of slag replacement to give the contractor, the designer, and the owner a handle on what are the different levels of performance that you can see when you're looking at trying to measure carbon intensity. So for example, I'm pulling some data here, 35 MPa from 2016, averaged across the industry. What we basically were doing was averaging every cement EPD, cement plant EPD from coast to coast. We calculated the concrete plant inputs for all 7 regions and then averaged them together. Then we took the mix designs for all 7 regions, averaged them together, and came up with this harmonized garbage that really doesn't tell you much. So we've decided to tackle it a little more properly this time around, and we've broken that data down by region. So it makes more sense and it gives you a better handle on what the actual carbon intensity is. So if I look at our 2022 data, 35 MPa C1 concrete, we have 4 Ontario cement plants averaged into the EPD. We've got just Ontario cement concrete plant data, and we've got just Ontario mixed design data. So again, we're trying to give you a more accurate information when it comes to that. We have just literally completed this work. We worked with Athena Materials Institute to do these industry averages both times. We just 2 weeks ago submitted to ASTM for third-party verification the data for all 7 regions. So by the middle of June, I was hoping it would be today, but by the middle of June, we will have new industry average EPD for ready-mix concrete for all 7 regions of the country. And again, just going back and having a quick look at some of the data from 2016 to 2022, looking at that C1 mix design. Again, when I look at the global warming potential, if that's one of the factors we want to look at, what we've gone from the average across the country was 417, where we're at in Ontario is 317. So 317 kgs of CO2 per cubic meter. But again, the technical part of me has to point out to you, we were averaging across the whole country before. Now we're drilling down just on Ontario. So it's a much more accurate data set. I also have to point out that the cement industry has improved significantly in the last 5-year period. And that's one of the challenges that we see when it comes to setting benchmarks and goals for projects is every time we do an EPD, it has to get better. If we're going to net zero, every 5 years, the benchmark has to continue dropping. So it's going to be challenging as we go through. So from an association standpoint, I just wanted to touch off on some of the key things. What we see as critical things, we want to provide the industry average data to the local design and construction community. So you know, for the types of concretes that we use on your projects, what are the average benchmarks? Like again, when we went through and did the data with our members over the last 6 months, if we were looking at a C1 concrete that we use in parking garages, we wanted average SCM usage across 20 companies so that we're trying to come up with what is the true industry benchmark. You want us to improve from that benchmark, but we got to set a valid benchmark so it's realistic. We want to make sure that we're using the SCMs that we currently have in the marketplace. And then from a concrete producer standpoint, the association wanted to be sure that each concrete producer had a calculator that could do a type 2 unverified EPD using the Ontario average data sets, so that, again, I understand there's a huge push for type 3 EPDs, and I fully support that. But we want to have simple tools that if you want to have a discussion with an architect, an engineer, an owner, or contractor on if we made minor modifications to the mix, what would the rough impacts be? You could use just the average data. It's far more accurate to get down to, instead of using Ontario averages, use your actual aggregate data, your actual cement data, your actual admixture data, and get more accurate tools, which Laura will talk about in a minute. And then the big challenge is dealing with specifications. People clearly want to specify GWP reductions. And again, it's, to be completely blunt, the industry has been focused first on cost, then on performance, then on ability to supply, and then on long-term durability. Carbon reduction is really something that we've just seen here in the Ontario market over the last five years. It's a huge opportunity for the industry to show its technical capability and to move forward. And we're very excited about the things that we have to offer. But the challenge that we have in the ready mix industry is we supply a plastic product. It flows down the concrete chute. It requires a contractor to move it and place it, and we have to wait for it physically to gain strength and stiffen and get hard so that it can carry load. So there's a huge interaction between, you can't just look at a table. We're going to give you a table that shows all the EPD values for different levels of SCMs, but there has to be that interaction between the designer, the contractor, and the supplier. What time of year is it? What are the specific site considerations that we have? We have to pump the concrete 50 stories up for a high-rise condo in downtown Toronto. All those factors have to be put in. So one of the great things about our product is we have great flexibility. The challenge we're going to go through over the next few years is how do we work together to understand the technical components of everyone's piece of the pie so we give the owner better value and lower carbon at the end of the project. But that's really what I wanted to touch on in my presentation. So with that, I'll hand it over to Laura.
Hi, everyone. Sorry, I just had a little bit of a cough attack there and I interrupted. It's very nice to be here today. Thanks for inviting me. Thanks for CLF to, how do I do this? Thanks for CLF organizing this seminar. So I work for Lafarge Canada, and just a little bit of an idea and explanation on who Lafarge is. We are part of Wholesome Worldwide. So we are a global entity and a global organization that is focused on sustainability, obviously now. So we have been dabbling around the conversation of sustainability for quite a few years now, and trying to put together some data, trying to focus on research and development and things like that. I'm not sure if you guys have seen this graph showing our net zero path. This is the Global Cement Association and the Canadian Cement Association. And the plan is, as we all know, to achieve net zero by 2050. And it's definitely possible. We're all going to work on this together, right? I always think if we got through what we went through in the last couple of years with COVID and snapping our fingers and working remotely, then we can handle sustainability, right? But the thing that I like to, the thing that is highlighted the most for me here is this 2020 to 2030, the slope of emission reduction required by 2030 to get us to that 2050 mark. And just a reminder, we're in 2022 right now. So in 7.5 years, we got to have some solutions and achieve that 2030 target. So I always point this out. Of course, with the global initiatives, we at Lafarge and Wholesome also have our net zero pledges as well. We do see the importance of reducing CO2. We have put together some numbers and put together some targets that I don't necessarily need to get into, but happy to talk about in the future. But basically by 2030, we are trying to tackle a 30% CO2 reduction. That's from the cement division side, the aggregate side, as well as the concrete side. So ultimately, we are a vertically integrated company. We have our cement production, we have our aggregate quarries, and we have the ready mix business kind of utilizing these products and putting them out the door. So we have a little bit of control internally, right? Within our organization, if we're going to tackle this climate challenge, we have some levers to focus on. So we offer a low CO2 concrete, and low CO2 concrete may be different for us in our definitions and different from yours. So I'm going to talk about, you know, the EPD type 3, for example. Those EPD type 3 verifications that are certified will ultimately compare apples to apples. They will ultimately compare what is in fact a true green concrete. So we are EPD certified at 31 of our plants in Eastern Canada. So Ontario specific is about 28. And we plan to have 41 EPD certified plants by the end of the year. This accounts for more than 85% of our volume because we focused on like the hot spots, right? So we have something called EcoPact. Why did we brand it? It was ultimately to change the way we think internally and externally. So you still have the standard concrete. Conventional concrete is still designed the same way. It's still going to exist today. It's going to still exist in a few years because we have to overcome certain challenges with low carbon concrete, let's say, and the materials that we use. So with standard concrete still being in the game, the way we have always designed the mix designs for standard concrete is, no surprise, lowest cost optimization. Obviously, our industry, the entire construction industry is a cost driven one. And so lowest bid gets the job. Let's completely be realistic, right? So lowest bid gets the job. Standard concrete is always cost optimized. So we developed an EcoPact brand, and we are calling it EcoPact so that internally and externally, people know that we are focused on CO2. So it's not optimizing cost, it's optimizing CO2. So two different paths, two different approaches to mix designs. And like Bart has said, it's very flexible. The product is very flexible. So some things that we're working on, obviously we have some limitations. Sarah mentioned a few, Bart's mentioned a few. There's some limitations, but there are low carbon products available today. So are they net zero? No, they're not net zero because I think we need a completely different reinvention of the wheel to get to that point. And hopefully sooner than 2050, but hopefully closer to 2030, but we'll see how that goes. You know, this is still a little bit early for Canada. Being a global organization, we do have the ability and we're fortunate to be able to talk to our colleagues all over the world. We are a little bit behind Europe, behind even Australia. Australia had concrete EPDs back in 2017. This is nothing new to them, and low CO2 concrete in Australia is the way of, you know, doing business. They are the green envelope that they're focused on. So we have EcoPact right now, and when we're basing it off of numbers that we have, like that Bart showed with that EPD document, when we're trying to reference where we're at, we are seeing we are up to like 70% CO2 reduction compared to some of these numbers. And so imagine achieving up to 70% CO2 right now with what we have and continuing to build and educate and basically ultimately gather data because we're early to it. So we have the EcoPact products that are available today, and this is not supposed to be a sales pitch whatsoever, but what I wanted to show was the next level. After the use of low carbon products, there is still a requirement for carbon offsetting. There is still a requirement because right now, the way we see it is there's no way currently to achieve more than 70% reduction. So we have to rely on something. Now, I will say that that is completely dependent on the ability to do more, right? Like we have, I'm going to say, like based on the you know, CSA standards and ASTM requirements and things like that, we can do more, but we have to you know, further develop new materials and things like that to be able to incorporate into our mix designs. So you guys are familiar with life cycle analysis. I like to point out, and I think it was on Sarah's slides, the embodied carbon portion for concrete is cradle to gate is what we call it. And it's scopes A1, A2, and A3. So basically everything that has happened right before the ready mix truck actually drives off the plant site includes all the carbon associated to the manufacturing, the transportation, the raw materials, everything associated to that is included in our EPD type 3 out of the gate. And we're doing other things outside of just the A1 to A3, knowing that that is a big, a very big portion of the numbers. I think in Sarah's presentation, it showed, was it 80 or 90% or something like that? So for us, past that 80 or 90%, what do we do next? We are trying to go through the electrification of our equipment, right? So we have quite a few trucks, ready mix trucks, especially in Ontario. So if we find ways to help with A4 through our, electrification of ready mix trucks, not suggesting that we'll have an electric ready mix truck anytime soon. It's a little bit long term, but again, in the interim, if we can find ways to utilize electrification, we will. So right now we are working within Lafarge. We are working on electrification of the ready mix drum. It's always rotating, whether they're in idle or anywhere else. So if we can reduce carbon just slightly, we'll work on it. And then there's a few other options as well. Like there is not just the A1 to A3 that we can help with. There's a few other areas and other scopes that we can compare, So ultimately, life cycle analysis, in my opinion, and again, it's just me and I'm just one person, but life cycle analysis truly is a measure of what we're doing moving forward, right? And we can run some exercises and we'll run some case studies and gather data and compare LCs using fibers in A5 or recycled concrete aggregate at the end of the life cycle, whatever it is. The true indicator of what we're doing to our planet is through the LCA. And yes, there is a need for some kind of data gathering, and thankfully Concrete Ontario is putting together some type of calculator tool. So in the interim, we'll have the opportunity to have EPD type 2s from all the concrete suppliers in the area, and hopefully encourage them to also get third-party certification. Type 3 EPDs are 100% accurate. So it's just, if you use 100% accuracy into analysis like LCAs, imagine what we can do with those numbers or data gathering or things like that. So people always ask how to specify, and this is, a big conversation. There's different things. Bart mentioned the use of GUL instead of GU, the use of supplementary cementing materials. Those aren't going anywhere. Those are a need for concrete design, especially in sustainability. There are many admixtures and constituents that you can add to kind of counterbalance some of these high SCM contents and things like that, and we try to focus on that. And there's a few more options. I've seen maximum GWP by product being specified. We've seen percentage reductions for entire projects at as a whole. And I guess in terms of the low CO2 concrete, and this is not just, I don't think, related to EcoPack, but I can only talk about EcoPack because I see the data for EcoPack. So what we're trying to focus on is having an option. This option here, the 30 to 50%, that's our comparisons, 30 to 50%. We want it to act the same as standard concrete, and we want to do it at little or no cost premiums. So that's what we're trying to do, because we truly believe that there has to be some kind of solution for today's industry and today's world. So if we can achieve a mix that can have low CO2 footprints and still achieve the performance that's needed on job sites, then at the very least, it might not be the most ambitious target, but where we are in the industry, at least we're doing something. Like, we're not just accepting, standard for what it is. We're trying to push our limits and try to reduce when we can. So most of the projects that I work on, and we develop LCAs as as a joint effort. It's more collaborative than anything. And that's what I do most of my time, to be honest. Like, part of my job, I'm going to say 80% is collaborating with folks like you and trying to learn, because we definitely do not have the answers. And the only way to be successful, in my opinion, is to collaborate and learn together. Like, it is a very, very ambitious goal, what we're all trying to achieve. And if we don't do it together with all the stakeholders, all the people involved, we probably will not be successful. So there are some limitations to increasing CO2 reductions. So as you go higher and higher, there are some limitations. And Bart mentioned it, high early strength kind of contradicts the whole sustainability piece. So high early concretes, we don't offer a low CO2 option for them. So typically when I'm working with folks like yourselves and putting together LCAs and to analyze different case studies, what we normally do is we choose the critical path elements to maintain either standard or EcoPact entry level to maintain project schedule, because at the end of the day, no one wants to increase project schedule. In today's time, every minute will cost $1. So usually it's like a mix and match and a custom design or a custom approach to the design, where we'll incorporate standard concrete for like the high early requirements, EcoPact entry level for critical path, and then you can go further when there is an element here and there that you do not need 28 days strength on, and your ultimate strength you would need at like 56 days, let's say. We can squeeze in an EcoPact prime there, here and there, and then basically maximize your CO2 reductions. I'm gonna just run through these because I noticed the time here, so we can have some questions. But EcoPact, people always ask, okay, is low CO2 concrete more popular in different parts of the world? What kind of case studies have you done? What kind of pilot projects have you done? Any buildings from scratch, from start to finish? So I include just 3 case studies. One is local, so York University, where we it was actually not a CO2 conversation at first. It was a client coming to us saying, this is what we need. And it just so happened that their requests and their requirements for that specific project fit in with an EcoPact prime. So why not do it? So we recommended it, and they were absolutely excited and happy to do so. So for 1,800 meters of EcoPact prime, comparing to like just the conventional mixes that we would normally do, we saw about a 393 ton reduction. And a little bit west of us in Western Canada, there was this project, Janine's repowering project, and they also had EcoPact low CO2 concrete, but it was just the first tier. So constructability stayed exactly the same. There was no changes whatsoever. And over the 5,000 meters, they achieved about 340 tons of reduced CO2. And a little bit further overseas example, we have a business in the Middle East, and Qatar worked on a 6 residential building at Lusail Hills, and the volume, it was a much bigger project than 11,000 meters, but 11,000 meters of it was EcoPact prime. So they were able to save over 2,000 tons. So it was very, very interesting to go through these case studies kind of worldwide as I was putting this information together. I guess I just have 3 takeaways. So one, the first takeaway is low CO2 concrete, maybe not the lowest, but low CO2 concrete is available today. And we're looking for collaboration. We're looking to work on things. We're looking to gather data. And so it brings me to point 2. The more we work on, LCA analysis, project to project, year over year, it's going to be some kind of measurement for sustainability as we move forward. And that's it for me. Thank you so much. And we'll have to answer.
Yeah, that's great. So maybe I'll ask the panelists if you want to come and join us at the front here. And we'll just open it up to any questions. If you have questions online, please just go ahead and unmute yourself, and you can turn on your camera if you'd like. So anyone have some questions to start with? I do have, we had a few canned questions to ask while waiting for you guys, but we'll get to you next, but let me ask my canned question first. A few of you had mentioned type 2 and type 3 EPDs, but I don't think we ever got a definition on that. Can you just explain the difference between a type 2 and a type 3 EPD? Maybe I'll just put this down. I think you can just sit there.
Can I?
Yeah.
Great.
It's easier.
Yeah, I guess we're really getting down to whether we're going to third-party verification for the actual environmental product declaration. So when we did our industry average EPD for the Canadian Ready Mix Concrete Association, we engaged in 2016, we engaged Athena Materials Institute to do the initial member survey across the whole country. They collected the data. And then once that data collection was done, that entire package was then handed off to a third-party consultant to do verification to make sure that the data sets that Athena used in their original calculations were correct. So again, from the association standpoint, our goal is to ensure that all of our members and the contractors and the consultants have the necessary tools to do quick and dirty calculations, but I've learned from talking to many consultants, quick and dirty is great, and there's a lot of huge benefits, as Laura pointed out, that we can get, but people want to know what's the actual improvement that we're seeing on our project. So by going to a type 3, now the producer is not using an average of the cements in the Ontario marketplace, they're using the actual EPD for the cement plant that they're using. They're not using an average haul distance for the hauling of aggregate from the aggregate pit location to the concrete plant. They're using their actual materials, the actual haul distances. So again, as Laura said, it's getting down to a far more accurate number. And if you're going to move to LCA analysis, obviously, if you're going to try and work that into procurement, using type 2 unverified EPDs based on averages of the industry is something the lawyers will love to do, because we'll be fighting about that forever. So again, that's where I see a huge push to, we want to have more accurate data sets in order to make more accurate decisions.
Yeah. So basically, just in summary, so EPD type 2 is using averages, EPD type 3 is actually third party certified, and basically has that stamp of approval with their documentation. And I guess the one big difference for me when I'm talking to people is the EPD document, once we actually submit it to your specific project and your specific concrete mix, we're held responsible to hold that value for 5 years. So it's a guaranteed CO2 footprint for that mix for 5 years. And with an EPD type 2, it's just, at the time of discussion, you run a calculator tool and let you know the number, but a year down the road, that mix might be a slightly different, things like that. So that's also why we have completely separated our branding from conventional concrete, so that even internally, we don't touch that low CO2 concrete.
Yeah, thanks. And my understanding is type 2s also typically are self-reported, and correct me if I'm wrong, but I think, yeah, type 3, it has to be third-party verified by another organization. So that's another big difference. Yeah. I think there was a question in the back there.
Yes, thank you for your presentation. You mentioned Canada is a bit behind on the global stage. Australia, Europe is in the forefront. Is it because of the government regulation are tougher there, or Canada is a bit loose? Is that why Canada is not in the forefront?
Yes, Sarah, just to make sure you heard that, the question was, why is Canada so behind, basically?
Yeah, unless Laura or Bart, you want to take a stab, I'm happy to jump in on this one if you want.
Please feel free to jump in.
Yeah, go ahead, Sarah.
So, I mean, I genuinely believe hard things are hard, right? And doing things like procurement policy or modernizing codes and standards are challenging. One of the things that makes it challenging in Canada is just our system of government, right? We're a very decentralized federation. Different provinces have their own leadership, their own government that have opinions on how they should do things. And of course, we have a national government that has its own opinions on how things should be done. And then let's add on the additional complication of municipal government. So if you look at where, building, standards are set around materials, building codes are made, they happen at all different levels of government, and there's not necessarily agreement and coordination between all of those levels of government. Add in complexities around funding, verification, even just getting agreement on the type of data that's used. Do you accept an EPD2 or EPD3? All of these things make it incredibly challenging. I would also add, my own observation. Canada, we as a people are very risk averse. Canadians tend to like to be not on the leading edge of anything, but we kind of like to be amongst the leaders. And you see this probably in no other place more apparent than in, code standards and procurement, parts of government, right? Where they're very, they have performance metrics around safety. They have performance metrics around, achieving value for money and cost. And we haven't necessarily, maybe a better way to say it is our climate ambition or our desire around achieving net zero in the built environment hasn't necessarily permeated through that risk aversion yet. I think we've seen in the past 10 years, I've observed a lot of progress, but it's still not enough. We still have a lot of work to do.
Any other questions?
Yeah, you suggested we do max GWP in our specs, and you suggested that's not necessarily the best way to go forward, or not always the best way to go forward. Understanding that the workability issues, constructability issues, timing issues, understood.
Yes, so, well, okay, now I'm gonna get in the fight. So remember what Sarah just said about us being risk averse? We're very risk averse in the concrete industry in general. I'll exclude you from this. So, because you're obviously ahead of it. But again, back to when I talked about what's critical to people, it's still low bid wins for most projects. And then it's meet the performance requirements, meet the plastic requirements out on the job site. So as a starting point, we're moving into a brand new way to evaluate concrete out on the job site. It's going to pressure us to make changes, but it's new to many of our members. Laura mentioned how many plants Lafarge has and Intercon have across the country, and they're definitely leaders there. But there's over 1,000 concrete plants in the whole country. And I would be shocked if you told me it was 10% that had type 3 EPDs at this point. So really, we want to walk before we run, and we want to, that's where we've seen people suggesting, let's set a GWP value. Our first fear was, is it the right number? And that's why we spent that's why we went from a national average to a regional average, because as an industry, we said, we have to know the numbers that are being thrown out, are they real? And can we achieve them? Or does it result in drastic changes? If you've already gone to a type 3 EPD, then you know the answer to that question. But for the bulk of the industry who's not there yet and will be there very soon, that's the first risk that we have to address. Then it comes back to constructability. And that's why, again, if you're going to put GWP values in, I'd probably start off by saying we want to see a target for the whole project so that there's flexibility, as Laura was talking about, on critical path elements that need strength in 24 hours. We can't give you strength in 24 hours and do drastic CO2 reductions at the same time. So let's leave those elements there. But if you're doing, like some of the examples she showed, mass footings, where you don't need strength for 90 days and you can put in 70 or 80% supplementary cement materials, and it's huge volumes of concrete. That's where, by moving to type 3 EPDs and having an actual carbon intensity, you can multiply the carbon intensity by the kgs of, or sorry, the cubic meters of concrete and get a real number. So that's where, as a starting point, as an industry, we'd like to say, let's first benchmark where we're at. So in my perfect world, every owner and every architect and every engineer would wait a year for us to look at, we now have our, well, in June we'll have our benchmarks, and let us look at where are we relative to those. If we start doing the math on, here's my GWP value, here's the actual kgs or cubic meters of concrete we supplied. Where are we relative to the benchmarks that we've just set? And then in a year's time, I will feel far more comfortable saying, okay, we can be a lot more aggressive.
So hence why we feel a little bit more comfortable, because we've been looking at the data with our EPD type 3s for the last year, right? So we've been about 12 months EPD certified. And so we were, nervous about it at first. And you start looking at the data and you start, doing what you can, manipulating some of the mixes, reducing CO2 where you can. And because we have this third party verified data, we know that it's ultimately helping. So I'm a fan of maximum GWP. Obviously, not everyone is. It's fine. We can agree to disagree, I think. But yes, you can do it in many different ways. You can have percentage reductions compared to the new Ontario standards, right? So now the Ontario standards are a little bit more relatable, a little bit more local. Let's have some percent reductions compared to that and be a little bit more ambitious so that we can achieve that graph by 2030 and 2050, right?
Yeah, and again, it's that game that we're going to, and that's where the consulting is such a critical part. You can't just look at the tables and go, oh, the GW, so the industry average for 35 MPa is 300 kgs of CO2. But if I go to your 70% simple slag, it's 150. I want 150 in all of my concrete. I stroke out when people think about that. But if you, as Laura said, if you sat down and you had discussions, even in the initial design stage, to say, where can we optimize? Where are these sections where we can get massive reductions? Then my heart attack will ease, the chest pain that I have will ease, and will be.
No, I 100% agree. You absolutely need to have a kind of like a partner to like run these numbers, run these EPs, and ensure that what you're specifying is legit and not maybe like impacting your project constructability. So in the efforts and in all the collaboration that I have done over the last 16 months or so, it was always like finding that perfect number. When a specification comes through and that number is not verified, it stands out to the people that know these numbers. So that has happened over the last 6 months where there was a maximum GWP for every concrete mix on a project, like the same number, and it's not possible. Like it's not possible. So there's that kind of stuff that's happening. So if you
would say an average be something reasonable, allowing people to go above and below.
There's no like one number, because the numbers are specific to the product. So imagine it like you're going to shop for some cola, Coca-Cola, and you're comparing like Coca-Cola Zero versus normal Coca-Cola. You're looking at the sugar content. So before you like buy this drink and drink it, you're seeing how much sugar content is in that soft drink, so that you see what it's doing to your body. It's exactly the same concept with concrete. Whether it's a Coca-Cola or Coca-Cola Zero, it's the same thing as saying like 25 MPa or 65 MPa, and you're looking at like different kind of nutritional facts that are going to the environment.
So we're in a beautiful concrete room from the 60s. Oh my God. So if this, it's probably not slab on grade, but if this was a slab on grade floor below us, you could optimize that for lower carbon intensity, because it's literally sitting on soil and you don't need the early strength. The ceiling above us, where the formwork is going to be removed in 3 to 5 days, that it's tougher. You can still do it, but it's tougher to reduce that. Ultimately, again, we've seen with supply chain challenges, other construction materials going up 100%, 200%, 300% in cost. That hasn't happened in the concrete industry. We're a very local material, local cost has always been a major factor for us. So that's another big change. Again, if money is not an object, if that's one of the factors that we're taking away, there's a lot that could be done to reduce that. But typically, because we're such a high volume material, like we're supplying 11 million cubic meters of ready-mix concrete in the province of Ontario every year. So it's a really high volume. You look at the number, we got 180 to 200 tower cranes in Toronto. There's with 20 to 40,000 meters of concrete in each one.
So maybe I'll just jump in there and say, yeah, when I talk to clients about how we can reduce the embodied carbon of their projects, often they have pushback. They say, it's too late. We don't want to change the design. And I always say, you know, there's things we can do with your concrete mix alone. If we only talk about concrete, and they won't cost you any money and they won't impact your schedule. And then they look at me like I'm lying to them. And then I start explaining things like Bart just said, you know, our slab on grades, let's let them dry or cure at 56 or 91 days, various options like that. But I'll pose the question to the panel. When is too late for those discussions? If the project has already been tendered, can we no longer change those mix designs, or can we basically change that right up until it's being mixed and brought to the site? How much lead time, I guess, do you need for those tweaks?
So speaking from just Lafarge standpoint, and the different tiers of those tiers through offering, the first tier is readily available anytime you want. So 24 hours in advance, you can actually order that concrete and have that certification if need be. But anything other than that, it does really require a conversation, because we don't want specifications to go out there with some of these products being specified, let's say, and the performance isn't the same, and like you are out there bidding at all different levels. There's tenders at all different levels. So do all the stakeholders within the bid list know what to expect in terms of performance? And if you are asking for it a little bit late in the game, your concrete finishers are not going to be happy with you. The foreman guys will not be happy with you. So to avoid that, like, you know, sour taste in their mouth regarding low carbon concrete, let's just have a discussion early on, and then that way we can like incorporate it at the time. If that's if you're looking for highest CO2 reduction possible. Every other time, last minute, you can still achieve something. So you can do something, even if it's, you know, like you said, slab on grade here and something else there. But we have like this off-the-shelf product offering to make your lives a little bit easier. That's how we went about it, so that we can do that switch change, that's quick change, you know, in a short time.
Great. So 24 hours, that's good. Now I can tell my clients, hey, Lafarge told me it's more than 24 hours before the mix. Yeah, sure.
How do we highlight, so when we tender, we have the DWPs in there, how do we highlight that so that it's not a surprise later?
Sorry, can you say that again? When you tender, you have what?
When we tender our documents, that like the max DWPs are in the tender documents.
The maximum global warming potential of the mixes.
I being surprised to the company provider afterwards, because they'll put tenders based on volume.
Because they're not reading this back, right?
We don't want that situation.
Yeah. So it won't be a surprise to Laura, but again, that's back on the ready mix associations across all the different provinces to make sure that we're providing training and education. Again, as I was saying, when we put our Canadian Ready Mix Concrete Association industry average out in 2016, we had multiple provinces that came back to us and said, why are we even bothering to do another one 5 years later? We never used it once. There's not one person that ever engaged us on this at all. And people in BC, Alberta, and Ontario didn't say that. But there's other provinces where they just like, this is not even on the radar. So from our standpoint, as a concrete association, our job is obviously, now that we've got these new regional averages, is to go out and do a lot of internal training to our own industry members on what this means and how, again, concrete producers know how to optimize concrete for performance. This is just a new performance requirement that we haven't been focusing on as much as we could have, and there's great opportunities here. So it's back on the industry associations to make sure that our members are aware of what it is that you're asking for. And then we'll have very gentle and loving comments on your specifications if we see things we really don't like.
Any other questions? Anyone online have any questions? We got one in the back there.
Yeah, when it comes to the developing concrete decarbonization technologies, strategies, process improvement, etc., how is the Lafarge faring compared to your competition? I think it's a French multinational company, right?
Sorry, just so that Sarah can hear. The question was, how is Lafarge comparing to its competition in the decarbonization game?
I'm definitely not answering that one.
Didn't want to leave you out though, Sarah.
So we are Wholesome worldwide, and I don't know if you know, but a few years ago, Wholesome and Lafarge merged. So that's two global beasts kind of coming together with the shared resources and things like that. I would say we are the world's largest building materials company, so hopefully we are good compared or better, or we're further ahead, let's say, because we feel, let's say, the pressure for leading the industry for sure. Quantifiably, I don't know what my competitors are doing, to be honest. I know what Lafarge is doing, and I can talk about what Lafarge is doing, but unfortunately, I don't know. All I know is that Bart tells me that maximum GWP means that some folks can't bid and cannot look at those tenders. So we're just a little bit in a transition. So we are, developing information and data gathering a little bit sooner. So hopefully we're ahead, but I can't.
And just, maybe I can just hammer home the points that I think you guys mentioned, but I wanted to make sure everyone's aware. So the Ontario Regional Specific EPD, as Bart mentioned, that's coming out in June, mid-June, and also Lafarge has plant-specific Ontario EPDs that are coming out at the same time. Is that right? Are they out already?
Yeah, we've had them for a year.
Okay, in Ontario.
In Ontario.
Okay, great. So so now you'll be able to look at what an Ontario average mix is and versus a low carbon Ontario mix from Lafarge. So that's pretty exciting. When I started working in this 5 years ago, it was just that one national EPD, like Bart said it was so frustrating. And my clients were like, what's our carbon footprint of our mix? And I'm like, well, if it was an average mix across Canada, they would be so mad at me, like, what kind of an answer is that? But I'm like, that's the best we have. So it's really exciting to know, that we have so much better data today than we did even 5 years ago. Any final questions? Yeah, Michael.
Oh yeah, thanks for the presentations. They're great. I guess just in light of recent IPCC reports on globally, we're not really meeting our targets. I guess my question is, there any discussion in the industry about accelerating the 2050 goals at all? I know it's pretty early on. Maybe what are the drivers that are needed to accelerate the decarbonization?
Sure. So I'm happy to jump in on this one. So yeah, of course. We had a board meeting earlier today where we were discussing our net zero roadmap and what it was going to take, and what interim targets are possible. So yeah, I would say it's always an ever present and ever live discussion. So in the cement industry, I alluded to in my presentation, right, we have both process and combustion emissions. So the combustion emissions right now, in some ways, are the low hanging fruit. I think what's really needed right now is, alternative fuel sources that are able to burn at the heat level that we need them to burn at to produce clinker, but that are also available. That is part of the challenge with a lot of lower carbon fuels. Sure, so there's broad availability of natural gas, which is I suppose a climate improvement over burning coal and petcoke. But at the same time, if we want to look to move beyond fossil fuels in the production of clinker, purpose grown biomass, are we burning waste? There are a whole bunch of different considerations that we have to have, and availability of those lower carbon fuels is certainly an important one, and it kind of remains a moving target for our industry as we look to 2030 and beyond. Certainly the continued conversation in Canada about how to unlock potential around commercializing carbon capture and storage is obviously one that matters to us. I think, the conversation around what to do with the carbon once you capture it, unless you're in Alberta, basically Alberta, Saskatchewan, or maybe some parts of northern BC, there's not a natural place to store the carbon. And so, I go back to conversations around either where do you store it, or probably better, how do you utilize it? And so there is a bit of a knowledge gap, of a technology gap on how we make that work. There are some Canadian companies who are starting to dabble in that space, but definitely there's room for more to be done there. I think, you know, the other thing is, you know, you need to look at various different like enabling policies like procurement. You know, I hate to say that it's all about procurement, but I've long believed that it is. You know, showcasing the availability of projects, or sorry, the availability of products, and some of the things that they can do, and using them in real world applications, and getting more engineers and specifiers comfortable with the types of materials and how they perform in real world settings is going to be also, you know, incredibly important to our success. And you know, then we could get into things around how the source of like supplementary cementitious materials will change over time as industry decarbonizes, right? We'll probably, you know, move away from fly ash and slag, and need to find other materials to help replace those over time. But, you know, that's kind of like a high level snapshot of some of the major levers that we're going to need to pull, you know, partially on the way to 2030, but definitely as we move towards 2050.
Great, thanks, Sarah. Yeah, I think there's going to be a lot of innovation in the carbon capture and storage, and how we can turn that into a you know, resource that goes into the stock feed of our mixes.
Yeah.
Yeah, for sure. Okay, well, I think we can call it at that. I think this has been a really great presentation. Thank you to all the presenters for taking the time and sharing your thoughts with us. It was really enlightening. And thank you to everyone who joined here today and online. Just a reminder that we do have another event planned coming up. I don't know the date. I don't think we have it in the slides, no, but we do have a session with the steel industry coming up in a month or so. So check out clftoronto.com for updates on that. And thank you to everyone online, and everyone here in person. Feel free to enjoy yourself with refreshments, and we can continue the conversation. So, thanks, everyone. Thank you.